Soon, we will extend this blockchain to support multiple contributors. With multiple contributors adding to the blockchain, miners will each have their own version of the chain. So say one miner wants to add a new block to the chain. Well, they will have to submit that new block for the other chains in the system to accept that in order to update the overall system, so that way everyone gets an updated copy with that new block loaded in. That way all the chains are consistent. However, in order for all of the miners to accept these new chains, there needs to be some form of validation to make sure that new block is valid and that they should actually accept it. The principal form of validation is to accept longer chains that come in. So say that everyone has an agreed upon blockchain that is already 3 blocks long. Now, one miner adds 2 blocks to the chain, but another miner adds 1 block at the same time. Well, by accepting longer chains that come in, the blockchain system can ensure that the agreed upon chain for everyone is always the one that had the most data within it. This also produces a situation which resolves a problem of forks in the chain. So it goes like this. Say 2 separate blockchain instances produce 1 block at the same time based off of the last block. So miner A produces a new block based off of the last block, as well as miner B. So both A and B create a fork in the system where they both produce a block based off of the same last block. And now half of the miners have the chain submitted by miner A, and the other half have the chain submitted by miner B. Now, eventually, the overall system needs to come to an agreement on which chain to accept. So which chain should all of the miners' blockchains eventually agree to? Well, say a miner extends upon miner A's chain by a couple blocks. This chain will now be longer than everyone else's chain in the system. Therefore, everyone will now have to accept the longest chain. This longest chain had miner A's block from the fork within it. So now the fork is resolved by accepting that original block submitted by miner A. Now, this does not mean that blockchains which had the block from miner B will lose that original block data, because now at this point, that block that did not get included before from the fork can now be added to the end of the newly received chain. Another form of validation is checking the hash value produced by each chain block. So every blockchain has access to the hash function, which generates the hash based off of the block's data. So when a blockchain receives a new chain, it can ensure that this hash was properly regenerated by regenerating that hash itself. If the hashes don't match, the data was probably tampered with, and therefore the blockchain will decide not to accept the new chain. Now that we've seen how blockchains resolve new chains from multiple contributors, let's add this chain validation functionality.